Welcome, one and all. I am Neil deGrasse Tyson, your personal astrophysicist. If you are seeing me now, you are live streaming our 19th or 20th annual Isaac Asimov panel debate from the American Museum of Natural History. And this was started back when Isaac Asimov died. We wanted some way to remember him. He was local to the Upper West Side of New York. In fact, many of his more than 600 books were written based on research he conducted at our institutional library. And so his family got together. They joined us to figure out a way to remember him. And he had covered so many topics in his novels as well as his books of nonfiction that we felt that a good way to remember him is to keep a living memorial in his name, the Isaac Asimov panel debate. And every year we take some new topic that's hot and interesting and unsettled, primarily. And this year's topic is the search for alien life on Earth and in the universe. By the way, this year we're celebrating, celebrating the birthday of Charles Hayden himself. Is it the 100th anniversary? I should have looked that up and I didn't. I'm sorry about that. But anyway, we're celebrating him, Charles Hayden, who first put out the money to bring the universe to New York City and create what famously became the Hayden Planetarium, where I now serve as director. I'd actually attended there as a kid. That's my first night sky. You grow up in the city, you don't know anything about a night sky until you go into a place where there's an expert and they can point it out to you on a dome, because the buildings are tall, the lights are bright, pollution was rampant at the time. And so planetariums have a way of influencing us all, I think, especially me when I was a kid. But let's get straight to this. The format of this evening is I have 5 panelists, each a world expert in why we have them on this panel. And you're going to eavesdrop on us. This is not a formal debate point counterpoint. That's not how we do this. There'll be topics that'll be put on the table, and each of us will explore them coming from the point of view of our own expertise, their own expertise. And you get to hear scientists thinking out loud. And it's as though you're eavesdropping on a conversation we're having at a conference lounge between talks or at the end of the day. And so that's the spirit and the soul of what it is we are bringing to you. So let me first introduce the entire panel, just so you get a look at them. All right. Natalie Cabral from the NASA Astrobiology Institute. Natalie, welcome to the American Museum of Natural History virtually. And thanks for being on this panel.
Thank you very much for having me, Neil.
Yeah, and we'll come right back to you in a sec. I just want to get everybody up there. Next, I have Vera Kolb of the University of Wisconsin and in the chemistry department. Vera, welcome.
Thank you very much for having me.
Excellent. And who else we have? We have Carol Cleland. Did I say that right, Carol?
You did.
Yes, excellent. And you're at the University of Colorado. A lot of snow there right now, I think. A little premature snow. And you're the Department of Philosophy there. All right. No conversation is complete until a philosopher says so. So you agree with that. Good to see. Next, we have Seth Shostak, an old friend, Seth, from the SETI Institute. There you go, Seth.
Well, it's great to be here where, the people are still smiling.
People are still smiling. Yes, because the whole world can't always be about COVID at every moment.
Well, California is burning. That's why.
Yeah, California's burning as well. Yeah, so these are all signs of some apocalypse. I'm not quite sure which. And last on this panel, we have Max Tegmark. Max from MIT Department of Physics, a longtime friend and colleague. Welcome back to you, Max. This is your third time on a Asimov panel, I think. Is that right?
Third time's a charm.
Third time. And Seth, this might be your second time. Is that right?
Yeah, that's correct. Yes.
Excellent. So it's great to have all of you. So let's go back. And I just want to hear if each of you take 30 seconds or so just to introduce yourself and what your expertise is that you're bringing to the table. Natalie, let's start out with you.
Yeah, I am the chief scientist at the SETI Institute. I have a background in planetary geology and astrobiology, and I explore extreme environments, and I've been doing some work on Mars as well with rovers.
So you have not been on Mars
With
you had-
rovers.
with rovers, okay. Just, I never know about you guys, where you've been. You say, I work on Mars. No, you work on Earth.
I work on Earth, but being a part of Mars missions with Mars Exploration Rover Spirit in particular.
Excellent. And you come to this as a geologist or as an astronomer?
As an astrobiologist with a background in planetary geology.
In planetary geology. Okay, excellent. And let's go to Vera. Vera, tell us about yourself.
I'm a professor of chemistry at University of Wisconsin Parkside, and my expertise is in astrobiology. I got my training in astrobiology from Stanley Miller and Leslie Orgel. I would like to take the opportunity to say to the audience, there is a nice book that everybody I think will love. It's called Astrobiology for a General Reader, a question and answer approach, which I wrote with a co-author, Benton Clark, who is also my fiancé. And for those people who want to go into depth, I spent 2 years of my life to edit Handbook of Astrobiology, came out in 2019.
Wait, Vera, aren't handbooks supposed to be little?
Well, you see, I started.
It's supposed to fit in your hand. You
Now I
plug in the
downsized
thing
to
up
that.
with your hands. So just, and you still have your fiancé after you finish the book. So that's a good sign.
No, actually, he proposed after we finished the book, which was
Okay.
very nice.
It's still a good sign. Still a good sign. Carol, tell us about yourself.
I'm Carol Cleland. I'm a professor of philosophy at the University of Colorado Boulder and the director of the Center for the Study of Origins. My area is philosophy of science. I'm especially interested in philosophy of the natural sciences, especially historical science, the geosciences, reconstructing the past. And I've been a member of the NASA Astrobiology Institute, both a co-investigator on several scientific teams and also a key collaborator on several scientific teams. And I've written a book on the quest for the universal theory of life and edited a collection of essays on the nature of life from a philosophical and scientific perspectives.
Excellent. Well, thank you for that. And just for those who don't know, the NASA Astrobiology Institute is a virtual institute. You can be a participant in that. There's grant money to support your research, and you would still keep your native affiliation wherever that is, but you collectively participate in this sort of unified search for life in the universe. Seth, also of the SETI Institute, just like Natalie. So welcome back. So tell us briefly about yourself.
Well, it's not interesting, but I'll tell you anyhow. I am the senior astronomer at the SETI Institute, which I think is a reference mostly to my age. The project that I'm most interested in is SETI, which is the search for extraterrestrial intelligence. In other words, looking for life out there that's at least as clever as your next door neighbor. And we do that by, well, just what Jodie Foster did in the movie Contact. We try and eavesdrop on radio signals. There are other strategies that we're looking at as well. And although I've written a couple of books, nobody ever proposed to me when they were done.
Okay. And you mentioned Jodie Foster in the film Contact.
Yes.
She used headphones to listen for aliens. Is that what you're doing right now during this session?
Well, I personally am not, but in fact, some of our experiments are running. At least I hope they're running, if they haven't burned to the ground.
Okay. All right, Max, tell us about yourself.
So I'm here at MIT. I'm a professor in the physics department. I'm also in the Center for Brains, Minds, and Machines, and also part of this brand new center we have on artificial intelligence and fundamental interactions. And I hope to bring two things to this panel. One of them is, during my work as a physicist, I've spent a lot of time studying our cosmos out there and mapping it and thinking about the physics of what limits we actually can place on life. And the second thing I hope to bring is from my work in artificial intelligence, which is what I've been doing mainly at MIT for the last few years, which I think can tell us a lot about technological life elsewhere in space, and even perhaps what kind of spacefaring life we humans might create.
So it'll be fun with you as part of this panel because you're the only one with no formal biology expertise at all. So,
but I do have a claim to fame that I married an alien, actually, which was a little bit related to the time when I wrote my first book. An illegal alien.
Okay, I got you. Undocumented alien, I think they call them.
Documented, yes.
So, but it'd be good to hear the, sort of the base physics perspective on what is and is not possible in the universe. All right, so let's get to our topics. Just so the public knows, I have a list of questions that I'll be bringing to the panel, and they've seen them all, but they're not bound to them. They can go wherever they want within them. And I have a steering wheel. I just want to make sure I get through the topics, but they'll take us whatever off ramps the moments require. So, Carol, let me just. No, I'll save that one for. No, hold on. We'll come back to you, Carol. Natalie. Yeah, we can't lead with a philosopher. That'll
that's where you should lead.
No, that'll confuse
Carol,
everything.
don't worry.
No.
Don't worry.
Or you should end with the
segue
philosopher.
to you. Neil doesn't know what he's getting himself into.
I don't know what I'm
here.
getting into. That's maybe a good thing. So Natalie, tell us from your side of the fence, what is life?
Well, the interesting response to that is that we don't have a definition for life, at least not one definition for life. We don't really know what life is. And basically, we're still trying to figure out. I think that, and the question I really like is that, is there a need for a definition for life? As somebody who is doing, experiment, I think that we can use some definition for life for a specific purpose. But if you are looking at what astrobiology does right now, it's looking more at what life does. So, the things we can measure, which is like metabolism, physics, and chemistry, that leads to the metabolic activity of life. But then, does that give us any answer to what life is? And then you go into the nature of life. And so either you are dealing with the piping of life, which I call the piping of life, like astrobiology does, and then we become plumbers. We are good plumbers. We are worrying about the pipe, what the pipe is, the interaction of the pipe with the water. But does that tell us anything about the nature and where the water is coming from? And then today, if you are going to other extremes, there are new theories. And I'm taking one off my hat here, but information technology or quantum physics are taking us in places where science and philosophy are getting much closer together. Theories like biocentrism are taking life way back at its most extreme quantum level, where you say everything is energy and information is only energy that is being understood when you can look at it and understand it. And if this is really that, then astrobiology is only telling us about life as we can understand it. But these new theories are telling you life is everywhere, and maybe the universe is alive. And so we don't define life, but then you just understand its manifestation and diversity. And I think this is beautiful. It's an incredible spectrum.
So it sounded like once you brought in information and energy, I know Max will have something to say about that in a few minutes, but does that mean there could be life out there that would not satisfy that sort of base criterion? I know what life is when I see it. Is it, that's the gut, that's life, that isn't. Are you saying there might be some ways that life manifests that doesn't satisfy that gut understanding of what life should be?
Astrobiology is still trying to figure out whether life is a transition or if it's something that happens abruptly because something, weird happened. But these new theories are telling you life is everywhere. There is no need to define life because the universe is alive. And basically what we call life is only what we can recognize as life.
Well, that's scary because there might be life staring us in the face and we don't recognize it as life. That I don't know how that encounter will end. I worry about that. Vera, what is panspermia?
Panspermia is an old idea proposed by an old Greek philosopher, Anaxagoras, who believed that universe is populated with seeds of life, and these seeds fell down upon Earth and started life. So at that time, it was just an idea, and about in 19th century, it started to look like a hypothesis. And at this time, it is definitely a hypothesis because we have found out that spores of organisms can survive in space. This was done experimentally at the International Space Station. And also spores can travel through space inside the rocks, which protect them from the radiation, and that is called lithopanspermia, again from Greek. Panspermia means seeds everywhere. Lithopanspermia means seeds are inside the rocks. And then finally, this hypothesis was strengthened by the discovery that meteorites can travel between planets, for example, Mars to Earth, and vice versa, and between other planets. So all of a sudden, what looked like an old Greek idea, now this idea became a hypothesis. It seems to have enough support to be considered seriously scientifically.
And we had a ready-made word for it.
Yes, definitely.
Already in the catalog. By the way, that painting above your head looks a little spermic. What's going on with that painting?
Yes, well, I'm glad you asked this. This is my favorite painting by an artist, Mark Dancy from Detroit. You cannot see all the details, but there are thousands of little specks of paint which look like stars. And there is this red balloon traveling through space. I saw it as a sperm traveling through space, trying to reach another planet in the universe. Although the artist named this painting The Apathy of the Stars, I call it panspermia.
Okay. Well, and all good art should allow you to interpret it in whatever way your feelings require. And if it's not, then what's it good for? Right.
Exactly.
So, Carol, you come from a whole other side of the fence here, and you're trying to blow open people's understanding of and their definitions of life. Where are you trying to send things? What fights are you trying to create? Really, is what I'm getting at here.
So I think one of the biggest mistakes is the whole project of defining life, the scientific project defining life, because keep in mind that
to define life or to find life?
The idea of defining life.
Defining life.
Yes. There are, I won't go into them, there are these serious logical problems that philosophers are well aware of with the whole idea of defining what are called natural kind terms, which are basically categories that are carved out by nature and not human understanding. But our problem with life is we only have a single example. All life on Earth is remarkably similar at the molecular level. We're all descended from all known life on Earth from a unique common ancestor. And I love what Natalie said about life as we understand it. If you try to define life, you're dissecting your current concept of life. You're presupposing that all life in the universe is like our form of life. And we just don't know that. We certainly know there are certain conditions that are probably similar between, and certain of them are going to be similar between our kind of life and other life in the universe, probably complexity and thermodynamic disequilibrium, extracting energy from the environment in order to maintain order and through an extended period of time against the, shall I say, ravages.
Wait, just to be clear, when you speak of disequilibrium, if we were in total equilibrium with our environment, we could not function. Yeah. Right? We have to be something really different to be what it is that we are, right?
And we know that life does that, but so do tornadoes and hurricanes, and they last longer than mayflies. So I think that it's important to keep in mind that, yeah, we do have certain things that are almost certainly universal for life, but a lot of the features that we think of as common to life as we know it, even natural selection in the sense of standard Darwinian evolution. What if you had a world which was, natural selection is really well designed for a world that is not too stable and not too extreme in its changes, so that organisms have a chance to adapt to the environment and to have the kinds of hereditary changes that provide them with the resources for natural selection to operate. But what if you had a world which was very slow and didn't have much in the way of extreme environmental changes? It wouldn't be particularly adaptive to have mutations, because you'd already be well adapted. Mutations also cause organisms not to be so well adapted. And so I think that we have to be very careful trying to extrapolate some of the things we think which are universal for known life on Earth to alternative forms of life in the universe, because it's going to be very environmentally dependent. Even though I think there are certain features that there obviously are certain features that are universal to all life, and our form of life exhibits those, but we don't know what they are.
Make an interesting point. I just never thought about it. If you had a completely stable environment, it might be possible to adapt your way into extinction because there's nothing to adapt to. And all these changes are happening beyond your control.
Or you adapt so that you don't have much in the way of mutations. That is to say, maybe initially there's a period of time and and the environment's very stable, and now it's maladaptive to engage in too much in the way of mutations.
So, okay, so you would mutate in such a way that you wouldn't mutate so much. That's what you're saying.
Well, I don't know how life starts, but if we assume it starts by, getting gradually adapted to an environment, and then the environment becomes very stable, then I think that the kind of natural selection and evolution that goes on Earth might be maladaptive. I mean, we are in a sweet point between changes happening in the environment too fast, where extinctions occur, like in Cretaceous extinctions when a meteorite hits and we almost lost everything, and environments which are very, very stable. So evolution is very well adapted to our environment, but it's not clear to me that a different environment.
I like the idea that evolution adapted to us instead of we adapting to evolution. Seth, you're, one of the letters in your acronym is an I, SETI, and that stands for intelligence.
Right.
So
that's why
let me pick up a baton from Carol, who she implicitly handed me, and I'm going to ask you. You have defined, presumably, ourselves as intelligent, and using that as a measure of the intelligence of a species you're looking for. Well, what is intelligence?
Yeah, well, I not having had any personal experience with it myself, I can't say too much. But fortunately, when it comes to looking for extraterrestrial intelligence, which is to say, aliens, we don't have to worry too much about these questions that Carol worries about, like what is life, right? Because we don't have to find life, we just have to find a signal that intelligence made. Now, you might say, well, that's a distinction without a distinction, but it's not really so. If you pick up a radio signal and that it's coming from the sky and it moves across the sky as the Earth rotates, and that signal is at one spot on the radio dial, the way WNYC is, for example. At one spot on the radio dial, you can say, well, that's not a quasar, a pulsar, any of those other kind of R's. It's a signal made by a transmitter. Now, what's behind the transmitter? Yes, maybe it's a little green guy, who looks sort of like us, and if he moved in next door, you might, invite him over to dinner eventually. But maybe it's nothing like that at all. I mean, it's not a very sophisticated idea that I've promoted occasionally, that in fact we're only here to get the machines going. We don't have machines that are intelligent enough to take over Neil's job, for example, although they probably could take over mine. But 50 years from now, that situation may change, and it may be that human intelligence, as nifty as we think it is, may be a very short-lived affair. And if that's the case, then most of the aliens are likely to be, or at least the ones we'd hear from, are likely to be machines. And in that case, this whole discussion about what is life would be like trilobites sitting around figuring out what the dinosaurs are going to look like. Well, they're going to be kind of flat and bilateral, and they're going to rove around on the bottom of the ocean, and all that would be wrong.
Okay. Did you just analogize us to trilobites?
The better of us, yes.
Just make a note of that. Max, you like Carol, you're probably on the same side of the fence as her from everybody else. I want to ask you, what is life? And is artificially created intelligence life in your definition?
I like to define life simply as a process that can retain its complexity and make copies of itself. And I like it so much that you'll even find the definition on my t-shirt here. And the reason I like to give such a broad definition of life is because I really hate two anthropocentric definitions, which I view as carbon chauvinism. My sons, Philip and Alexander, I looked at their textbooks from the Winchester, Massachusetts school system, and where they defined life as a laundry list of criteria, including being made of cells and so on, which it seems so narrow that I'm almost certain that if Seth finds life in another solar system, it's not going to meet, that textbook definition. Then you asked about intelligence. There too, I like to think about it in terms of a process of information, an information processing process, which is simply in the case of intelligence, able to not necessarily reproduce, but able to accomplish goals. And the more complex the goals are, right, the smarter it is. So it's very easy to imagine that we could design future robots and other AI systems that also meet the definition of life. But we could also make things that are intelligent, perhaps without being alive or conscious, so that they could help us with things without us having to feel guilty about switching them off. In summary, I feel that the essence of both life and intelligence should be thought of not in terms of what kind of atoms go into it, but in terms of what it's actually doing as an information process.
So was this the foundation of your recent book, Life, was it, I lost track, 2.0 or 3.0?
3.0.
So what's Life 1.0?
So Life 1.0 is really dumb life, like bacteria, and no offense to trilobites. It won't learn anything during its lifetime and has its intelligence basically hard-coded in by its DNA. And I call us here Life 2.0 because unlike bacteria, we actually learn stuff during our lifetime, right? We can install a module in our brain that speaks a new language or knows a new job skill. So we can install new software in our brains, basically, but we still can't upgrade our hardware. Life 3.0 can replace not just its software, but also its hardware. And the sort of future technological life that Seth thinks he might find, right, would probably be Life 3.0. If it decides to be stronger or faster or whatever, it can upgrade its hardware.
So can I just respond to Max?
Yeah, please, jump right in.
So Max, I agree with you that it's probably a necessary condition for life that it be a phenomenon or a system that's complex and maintains itself in a sort of out of equilibrium state. But that's not a definition. The problem is you've just given some general conditions, and again, we have tornadoes and hurricanes, which last a remarkably long period of time, as we all know, that do the same thing. So to get actually at life, unless you're going to count all kinds of phenomena as living that we don't normally, you're going to have to add some other conditions. And that's what I don't think we have a good understanding of, which is why I hate people who talk about that. I don't hate people. I hate definitions of life. Sorry, I like
hate you, Max. I knew. I felt it.
But I think the whole project of defining life locks you into this box because definitions give you necessary and sufficient conditions. They tell you what life is, and anything that doesn't fit into the box is immediately consigned to the non-living category. So I think the word definition is really problematic.
Wait, Carol, but there's possibly another way to imagine this. You can define something, and depending on the definition, it could embrace something you never imagined it could have embraced before. For example, if we agreed in the biology books, metabolism, it was your son's book, Max,
right?
Metabolism,
cell,
it would have to reproduce itself. And you could, if you looked at stars, they reproduce themselves. They have a metabolism. They're born, they live out their lives, and they die. So there's certain definitions of life where stars are alive.
Yes, and the great Immanuel Kant, very famous as a philosopher, and the discovery of as an astronomer, I think he discovered the galaxies
Well, the nebula hypothesis
Right, the nebula
was very
hypothesis.
popular and correct.
He and other people, going back to Aristotle, did wonder whether stars were alive, because on Aristotle's definition of life, it turned out that the very fact that everything on Earth stops, you push it and it stops. But of course, we have in the heavens these bodies that continue moving. And so the view was, he thought that motility was a defining feature of life, because he thought that the natural state of motion was rest.
Well, that's why we don't learn our life lessons from Aristotle.
But that's also a lesson.
Galileo came along.
We may be a bit like Aristotle in our current state of knowledge.
Oh, I see. That's the analogy.
Yes, that's the moral.
So let me ask you, Natalie, I just try to understand something. You look for alien life, I call it alien life, exotic life on Earth, because there are places that have been sort of biologically distinct, separated for immense periods of time, right? So you're intrigued by places on Earth that has truly exotic life. But if we agree that all life on Earth has common DNA and a common single-celled ancestor, how alien is the life that you're finding on Earth? It's just less familiar to you. Why is that a useful model for anything you might look for anywhere else that's not Earth?
I think that's a fair question, except that I wouldn't call this alien. I wouldn't say it's isolated. Nothing on Earth is isolated. We live in a system, and this is maybe something that people have a hard time, figuring out, especially right now, that everything you put in that system is going to come back at you and bite you sometime. But let's say that where we go to places that are what we call extreme environments. And they are producing very good analog environment, which means that they are similar to something. And those something are like the very beginning of Earth history, very different conditions, where you had lots of ultraviolet radiation coming at the surface because there was no ozone layer. But these conditions are also very similar to what Mars was at the time. And we'll go back to those, definition of what habitability is and all of these things. But imagine that you have conditions that are very similar from one planet to the other very early on. And the stuff that makes us, like carbon, like oxygen, hydrogen, and nitrogen, etc., it's also very common. And we also have found organic molecules on Mars. We know that they are there. Organic molecules are not life. They are the bricks of life, just like Legos. They are only Legos when they are spread on the table, and then you can put them together, and they may become more or less complex, right?
But we got to complete the analogy. So early life would have been Duplos, and later complex life would be Legos, right? That's how
exactly. No, but the point is that when we go to those places, we can look straight in the eyes, and I don't know if bacteria have eyes, but we can look at these very, very ancient and primitive organisms that are telling us something very profound about what life was early on, and in conditions that are very relevant to what, say, Mars or any other planet for that matter, we can now extend to exoplanet because we have this gallery of new planet. Try to figure out what life would respond to extreme environment that are analogous to different planets elsewhere.
Okay, so I had not fully appreciated that important dimension of that work. I kept thinking of it as it's an exotic life form and you don't find it anywhere else in the world, so you study it. But if that environment matches some other environment we know that's not on Earth, you will learn things from it. But let me ask, so Vera, if we go to Mars and we do find life of the kind Natalie is imagining, or that you might even be imagining, might it have DNA? Is there anything that would suspicion could DNA be universal in the same way geologists expect the rocks to be similar? Iron oxidizes on Mars just the way iron oxidizes here on Earth. Could there be some, and I bet Carol has something to say about this too, about a universal understanding of life, but could DNA, as complex as it is to us to think about, could it be a universal thing that biology does?
Well, let me answer first this way. The first question is is life on Mars, if we find it or its remnants, the same as life on Earth in terms of DNA? Because you were specifically focused.
I think she froze.
It's that Martian environment.
Yeah, the Martian. Oh, wait. So, Vera,
Yeah.
you're back.
My
Could
answer
you give us
is-
that sentence? Could you give us that sentence one more time? Because you froze up on right in the middle. We think
Oh,
Martians
okay.
did it, but okay.
Okay, so to answer your question directly, if we find life on Mars or its remnants, is DNA going to be the same as DNA on Earth? This is your question, the way I understood it. And my answer is the following. There are two possibilities, two main possibilities. Either we will find the same type of DNA as we have on Earth, which could indicate panspermia from Mars to Earth, because there is currently an understanding that life could have started on Mars first and then was transferred to Earth via panspermia. Or it could be different. However, in my opinion, DNA or its functional equivalent, the emphasis is on functional equivalent, must exist as part of any life. Now, let me support this somewhat. When you think about DNA or RNA, which are on Earth right now, there are literally millions and millions of years of evolution where this was perfected. DNA was perfected for its function. And when chemists try to make DNA lookalikes, thinking maybe DNA lookalikes could be important for extraterrestrial life, they did two specific things. They tried to change the backbone of DNA from phosphates to sulfones, and they found out the whole thing collapsed. It could make a helix, it just coagulated and collapsed, which means there were some requirements for this backbone, had to be repeated charge. Another thing chemists did, they said—
Well, you said it have to be. Maybe they're just not clever enough.
Well,
Why
I
do you
was
say it
going to
has to
comment
be?
on this in a second. In another attempt, and then I'll comment on this if they're clever enough. So another attempt was, why do we have to have ribose? We could have other sugars. And Eschenmoser, a very talented chemist, basically synthesized all different sugar analogs of DNA and found out, by the way, the previous work was done by Benner with sulfons, and found out it functions, but not so well. Now, talking about not being smart, with all due respect to my fellow chemists, and I'm one of them, I think are very smart. But you cannot do in lifetime of a chemist what evolution did in millions of years. So chemists against the evolution, chemists lose.
Okay. Carol, this problem of a sample of one, it plagues all branches of science, and you're a philosopher of science broadly, as well as your specific interests. So how do you as a philosopher think about the singularity? No, I can't use that word. Singularity.
No.
Max will get on my case. How do you think about this, the problem of a singular genesis for anything?
So I think in general it's a problem, but we're in better shape with regard to other areas of science because we have more than one example. We have no evidence, for example, that water on Earth is distinctively a single example, like we have evidence that life on Earth comes from a single example. And the evidence for that is just what Vera talked about. I mean, it's actually narrower than that. It's nucleic acids, where we know that there are alternative bases that could have created nucleic acids that would be perfectly functional in the right organismal environments, except they aren't used by our form of life. Same with proteins. So we have reason to believe, unlike we do for other phenomena, that we really do have a single example. And the problem with reasoning from a single example logically is just very profound. I mean, if you were an alien and you came down and you were interested in coming up with a theory of mammals, and you had only zebras to look at, what would you emphasize? What would you think would be the general features of mammals? It wouldn't be
all mammals have stripes, of course.
Yeah, exactly. It wouldn't be their mammary glands. Only 50% of them have them. So it's only
and they're tasty to lions. Yeah, this is the total conclusion.
But it's really important, I think, to see that biology is in a position that other fields like chemistry and physics aren't, because we have good reason to believe that the central category, life, as we know it, is descended from a single example. And we don't know what the alternative possibilities are. Maybe Vera's right. Maybe always life uses nucleic acids. But it's not clear to me that environments very different than Earth, such as Titan, Dirk Schurk's macaque, has, for example, argued that most of our laboratory work on silicon as a non-carbon-based form of life talks about how it doesn't make very good polymers that have the kind of characteristics that, say, DNA, especially, and proteins have. But under environments on Titan, for example, he argues there's some reason to believe low oxygen, very low temperatures, no liquid water, it can form much more complex polymers that would have the capacity to perhaps provide us with an informational molecule. I just don't think we know what the.
So Vera's point was that if it's not DNA, it's got to be something that codes information.
Yes,
and Max, if we're trying to code information, does it even have to be molecular? I mean, that's another kind of bias. That's a molecular bias, if you will.
Yeah, let me give two answers to that. If we're trying to code information in a way that evolution can evolve from scratch, then it's going to be very limited. There's the range of solutions it has to be made out of the molecules that are abundant in the biological environment. It has to be an organism that can self-assemble and maybe and so on. Whereas if we get to design it with our intelligence, now you don't need any of that. There are so many more possibilities, right? And I think for that reason.
Yeah, but to Vera's point, we do invoke our intelligence, and it's human beings working over several months or years, and we're not getting it, but nature had 1 billion years to get it right. So what do you mean? Let's use our intelligence, and we can figure it out.
What I mean is, if you zoom out and look at this in a more cosmic perspective, then I think in our universe, life will probably end up being like a 1-2 punch. First, it takes a really long time for life at our level to evolve. We've been sitting around. Our universe has been sitting around for 17.8 billion years until the Asimov lecture series was launched, right? And then in very short order, we went from inventing fire to inventing smartphones to flying into space and so on. And we now realize from the laws of physics that it's actually pretty easy to build technology that spreads life to other solar systems and ultimately even other galaxies. It can happen way faster than the 13.8 billion years been waiting so far. So I think when we look for advanced life elsewhere in our universe, I agree with Seth that it would be very unlikely that the first life we find is still stuck in stage 1, its biological stage. It's much more likely that we'll see something which has transitioned to a designed technological stage. And in that case, they're not going to be using information storage in DNA. They're going to be using something much more efficient that they invented.
So can I just say something here? I agree with Seth, but not necessarily with you, Max.
All right.
And this is the sense in which I agree with Seth. I think that when you talk about intelligence, that robotic forms of intelligence are likely to be existent in, maybe wandering the galaxies. I don't know. But I think that calling it life, information, purely informational, non-physical or non-chemical phenomena like this, calling it life, that's a different issue. For example, you can imagine a simulation of water in a computer, a very complete, very accurate simulation of water, but you really want to call it water? Are the chemists going to be very interested in it? So I think life is more like water than it is like intelligence. And that's, by the way, a philosophical.
But we got to pause for a second on that. Life is like water.
It's wet.
Well, let me get back to that in a second. Natalie, Carol mentioned Titan several times here. Titan, a moon of Saturn with a very thick atmosphere, and you study exotic environments. Is that environment too exotic for you to imagine life to thrive in? Given the very cold temperatures?
And Titan is really about a different chemistry from what we know. But, it's always the same debate. We have to start somewhere. So we start with the environment we know. If we take what we know and we just export it to Titan, then we have a problem. But it might be that Titan came up with something completely different. And again, this is not my area of expertise. I'm not a chemist. But what we see in the atmosphere of Titan is the formation of organic molecules, and they are raining down. They are raining down on an environment that is very exotic to us, like ethane and methane oceans. We also know that there is a water ocean under the surface of Titan. So what if those molecules are actually penetrating in the subsurface and reach that ocean? We don't know. We really don't know. But
you're still trying to eke life as we know it out of an environment that
because
could be
this is the
life
only
as we
thing I
don't know.
can do at this point in time. As I said, I am not a chemist. I am not a model and a chemist. Somebody like Vera, who is doing physics and chemistry, might be able to take those molecules that we know and project them into an environment that is exotic. And this is basically what we are trying to do right now when we are going to those extreme environments and trying to understand how life can adapt, how far it can adapt, how can we stretch it. And obviously, this is life as we know it. But can it adapt to some of these environments we see in the outer solar system? For instance, is life possible on Pluto, right? Like 4 years ago, I would have waved my arm and say, you're nuts. But see what's happening. Charon and Pluto, they are pulling on each other. There is energy, there is shelter, there is et cetera, et cetera. And
Sharon and Pluto's moon, Sharon.
Yeah, Sharon. And so you see those words that we are learning about with Kepler and with TESS and soon with James Webb. We have to start somewhere. I think that it's absolutely right to understand our constraint, but it's also fair to say that we have to start with something we know and move from there. And I think we are doing pretty good with that. We are starting to stretch, our gallery or our zoo of potential habitable environment. And by no means in my mind, I am constrained or limited to search for life as we know it. But I am certainly more familiar understanding the constraint of such life and trying to expand them somewhere else.
Let me ask you, Seth, is there an analog to this problem in the SETI world? Because you're assuming they're using radio signals. There's just a lot of assumptions going on here. Yeah. Is there someone stepping out of it and say, maybe they'll try to communicate in a whole other way? Let's be more inventive than that.
Yeah, well, certainly a lot of my correspondence speaks to that. By the way, I do feel that I should point out that the namesake for this debate, Isaac Asimov, actually wrote a paper on alternative chemistries for life. And so he investigated, whether, for example, silicon-based life, which is the choice of 9 out of 10 Hollywood screenwriters, under what conditions would that be possible? Anyhow, not to take things away.
But just to clarify, because if people don't remember their chemistry, silicon pops into the creativity of screenwriters and storytellers because it sits directly below carbon on the periodic table of elements. Yes. And as you might remember, all the elements in a column make similar families of molecules to each other. So the notion that you just swap in a silicon atom with a carbon atom and then replicate life, silicon-based life. So just make sure everybody's on the same page.
Yeah, and underneath silicon, I believe, is germanium, and underneath that is tin. And we do have an example of tin-based life in The Wizard of Oz. But
okay.
Leave that aside.
The only thing that is funny with silicon life is that they are actually coughing sand.
Yes,
I'm sorry, they are what?
They are coughing sand.
Coughing sand. Well, they should get tested. That's all I'm going to say. I'm sorry.
Well, go on.
No, your question. You better repeat it because It's been
Oh
so
yeah, no.
long now.
I was headed somewhere else. I just wanted to hear from you how inventive people could be.
Oh,
Because you're still listening for radio waves. Maybe they're
well, yes, you're right, and there are plenty of people who will say, well, radio, that's so old school. But of course, it's not really old school. Radio is a technology. Television is radio, right? I mean, the internet is your Wi-Fi. It's radio. It's all the same from the standpoint.
Seth, you sound like an old man on the porch in a rocking chair, saying it's all the same. These youngins, what are they doing?
Well, that's right, and I find myself doing that more and more often. But one tries to think out of the the quadrilateral or whatever, because in fact we're already looking for example, flashing lasers in space. There are several experiments at the University of California, Berkeley, and SETI Institute to try and find communication that way, and you get more bits per second with that kind of communication. So maybe the aliens are doing it. But I would suggest to you that an alternative approach, which I've become enamored of recently, is to look for the most advanced societies, because those, if they are societies, at least the most advanced intelligence, because they're likely to have done the most to make their presence obvious, or not obvious perhaps. And that is to look for artifacts, right? If you have a really advanced society, maybe they've just built a giant, what's called a Dyson sphere, a big fleet of solar panels orbiting in their solar system to collect all the energy they need. Or maybe they built something else big, something obvious, something that isn't natural. Maybe they've rearranged star systems. Maybe they're even trying to
Are
change...
you looking for this? There's a lot of maybes. I don't hear you saying that you're looking for it.
Well, are you old enough to hear this story? Okay, let me say that we haven't actually. That's very hard to do, actually. Looking for artifacts is a great scheme. That's the way they found life in the 19th century, or intelligence. They looked at Mars and they saw, crisscrossy lines, which they assume were canals. So it has a long history, but it's not prescriptive. It never tells you this is what you should look for. And that's the problem with it. But all astronomers should pay attention.
Vera, what pre-life chemistry is required to get life as we know it, or maybe as we don't know it? Because all biology is chemistry, manifested at some complex level. So how much attention is given to what the pre-life conditions need to be?
Prebiotic chemistry, which is chemistry which occurred before life and occurred naturally without any outside investigators, obviously, intervening. This type of prebiotic chemistry has been now part of laboratory experience, and we have made tremendous progress. What was done before, for example, nucleotides and nucleosides, which were very difficult to be prepared directly from nucleobases and sugars. Now, chemists, notably Sutherland and Powner, found creative ways to make these prebiotic chemicals. And so, to answer your question, I do not believe that prebiotic chemistry right now is a big problem for our understanding of life. What is the big problem is how the abiotic to biotic transition occurred. So you can think about abiotic chemicals. Let's say they were all made on early Earth or early Mars or other planets. They were made by these chemical pathways, depending which type of chemicals they had, but these chemicals were pretty similar. So now we have a heap of chemicals, okay, a heap. That is not life. This heap, to become alive, has to become a system. Now, what is a system and how does system differ from a heap? In the system, the parts interact among themselves in a complex manner. So life as we know it has three subsystems: metabolism, information system, and a membrane system, and it is a part of a larger system, which is environment and biosphere. So this is the big system of life. And then we have abiotic heap, if I may say that, and we do not know how the transition occurred. So this is the biggest knowledge gap in the theory of life. And we believe that we can possibly solve this through some more experiments. There are experiments along the lines of synthetic life, Craig Venter and others. There are also
Just to be clear, synthetic life is people creating life in the laboratory.
Well, we haven't done that yet completely, but you can sort of take a cell, get its DNA out, and put artificially made DNA into a cell, and cell functions. Okay, so we have not made life from scratch, but I would not be surprised looking at the tremendous progress. Think about the fact that DNA was discovered in 1954, okay? And what we have now is tremendous progress. So I think if we make any sort of synthetic life, may not be the same replica as our life, which is a historical process.
But Vera, didn't we all see that movie where we made synthetic life, and it didn't end very well? Just
I stay away from any science fiction movies because science is much more mysterious to me than science fiction movies.
So they asked Ray Bradbury, why do you write such dystopic future sci-fi novels? Is this what you think the world will be? And he says, no. I write them so that you'll know to avoid them.
Okay. I think, anyway, what I'm saying to you is that in terms of your question, the starting materials are not so important as this transition. And also, the most important thing is we will make functional equivalents of proteins, of enzymes. And there is no algorithm by which we can make an enzyme. For example, Stuart Kauffman had this great thing. He says, you cannot have an algorithm for screwdriver, what screwdriver can do. You can describe 2 or 3 functions, but there are myriad more functions that screwdriver can do. So for us to lock our thinking into chemicals which can produce exact enzymes as we have, I think it's counterproductive. It could be anything with the same function. So we are looking for functional equivalents rather than exact replica of what we have.
Could it be that you need an enzyme to make an enzyme?
Yes. No, actually, this is a very good question. And going back to the screwdriver, the primitive enzymes, and this is really fascinating. The primitive enzymes they could do anything. It's like your screwdriver. If you look at what people have who are not mechanically oriented in their toolbox, they have pliers, a screwdriver, and a hammer. Okay. You can do lots of things with these primitive enzymes. And they're kept through the evolution. Why? If everything goes wrong, you can always fall back on these old enzymes which can do anything.
I think a little bit of glue might help too.
Yes.
Carol, let me ask you. The word biosphere was mentioned here, and in researching your own professional publications, I came across a shadow biosphere.
Yes.
Could you tell me what that is?
Yeah. So I coined the term shadow biosphere about 2003, and a paper came out with Shelley Copley on the topic about 2005. And the basic idea behind a shadow biosphere is the idea that there may have been more than one origin of life on Earth. It's completely compatible with the little that we do know about the origin of life on Earth, and we know that there are. I think Vera mentioned this. There are alternative suites of, and Steve Benner's done a lot of this work, alternative suites of amino acids that could make proteins that were perfectly functional in the right organismal environment. Similarly, there are nucleobases, different sugars that could make, nucleic acids, which are different than our nucleic acids, that would be perfectly functional in the right organismal environment. But they don't exist. All life on Earth has just selected a small suite of all the amino acids and nucleobases that are available in nature, abiotically, delivered in some cases by meteorite, produced in hydrothermal activities and other cases. So our form of life has just used a small suite of these. And if life originated in Earth, and Vera brings up panspermia, and certainly that's a possibility that life itself or some of the basic building blocks of life, perhaps proteins or some oligonucleotides, were delivered to Earth by meteorites and basically seeded Earth in some sense. But if life did originate in Earth, then it seems that all the building blocks for alternative forms of life were available at the time, we don't know when, that life originated in Earth. And so there would be different, shall we say, cradles of life with different chemistry. And I see no reason why they wouldn't have produced early forms of life if life is a natural phenomenon, not a scientific miracle, but a natural phenomenon that arises under the right physical and chemical conditions.
Well, so where is it now? I mean, so because if life arose so quickly, as evidence suggests, then why doesn't it keep arising all around the world in whole other bio pockets? Is that what you're referring to as a shadow biosphere?
It could be still arising, but the conditions were very different back, during the 4 billion years ago. What I'm more interested in is whether or not there could be microbial forms of life. We know that multicellular organisms are fairly rare. They arose less than a billion years ago, and the Earth is 4.5 billion years. So most of the history of life on Earth has been microbial. And the question is, could there be actually unrecognized microbes on Earth that are descended from an alternative origin of life? And it turns out that the tools that microbiologists use to explore the microbial world would not recognize it if it existed. Those are microscopy, and I don't want to go in. I can go into more detail, but microscopy and cultivation and metagenomic methods. Metagenomic methods they require hybridization, and the hybridization requires similar, nucleic acids that differ even modestly. Different code.
So it could be sitting under our noses, and we wouldn't know.
Literally. And what we know about microbial communities is they contain a variety of low abundant varieties of microbes, and along with abundant microbes. It's not as if they would be necessarily outcompeted. Microbes are quite friendly with each other, it turns out.
Natalie, what are biosignatures?
Oh, yeah. I'm sorry.
Go ahead.
So Natalie, you had a comment on
Carol's. To comment on what Carol was saying is that from the astrobiology standpoint and the exploration standpoint, the search for life beyond Earth, personally, I think that, engaging ourselves in trying to understand the shadow biosphere and how to figure out if there is another type of life on Earth that we cannot recognize is one of the best avenues, and probably one of the one that will take us the most rapidly to find life somewhere else, because this is typically the kind of thing we need to do. We need to actually push the boxes we have put ourselves into. The shadow biosphere is one example of the type of intellectual framework, I would say, that we need to pursue in the same way that I see theories like biocentrism today that are blowing out of the water anything we think about life, and what is life and the nature of life. I'm not saying they are true. I don't have the academic background to understand everything, but I know for a fact as a scientist that by exploring those avenues, we are going to understand what is right, what is wrong, and expand our horizon. And so this is what I'm saying. I can talk to you at length about biosignature. I'm going to talk to you about biosignature as we know it, as we know them. And back again, we are here on Earth. Biosignatures, they can be chemical, they can be physical, it can be a mound of stromatolite, those little blue and green algae that gave the first fossil on Earth 3.4 billion years ago in Australia. People are actually still debating, knowing whether it's life or not. There are now other studies that are telling us that we have direct or indirect traces of life, and some of the indirect traces of life, if those studies are right, they might be 4.28 billion years old. These two blew my mind away, because if that's the case, it just means that life was there as soon as the crust of our planet had cooled down. So that tells maybe something else about what Vera is interested in, which is panspermia, or the ability of life to be part of the planetary process. So, I've been hearing a lot of things tonight up to this point, but it's all very much so into what we are used to, into the intellectual framework and the box we are used to. It's a lot more exciting and more thought-provocative to just push us, those walls and those boxes and collapse them. And I think that in many ways, what Carol is saying, what biocentrism is saying, is bringing those thoughts together, and might be the best to take us to life beyond planet Earth and thinking about life as we don't know it.
Vera, is intelligence inevitable in an evolutionary arc? Wait, I can't hear you. Try again.
Can you repeat the question, please?
Yes, I can, and we do hear you. Would you say intelligence is an inevitable on the path of the evolution of life?
Well,
in the growth of complexity, molecular complexity.
Well, I would like to answer this question two different ways. One is, we really do not know what intelligence is. So if we...
Seth knows, by the way.
Well, yes. But, for example...
It's a machine sending signals. That's intelligence.
If we try to define life, let's say, by using a laundry list of characteristics of life, and one of these characteristics is intelligence, then bacteria would not be alive, because we would have intelligence, but bacteria don't. This is one issue that we have. We always think that intelligence belongs to us, but the lower organisms don't have it. Still, I would say that even the lowest organisms act into their own behalf. They know how to survive. They know how to swim upstream, bacteria, to get some sugar. Not to talk about mammals. If you have a cat, let's say, you look at in cat's eyes, you see devotion and emotion. So, okay. So this is...
No, I see that they don't really care about you at all. This is what I see when I look at it.
They don't, absolutely. And that's why you desperately try to make them love you. Okay.
Or they're putting on a good act if they do. Yeah.
However, to answer your question more directly, you're saying, is intelligence inevitable? Philosophically speaking, there may be two different philosophies which claim progress of matter, evolutionary progress of matter towards the highest level that we have now, which is intelligence. I personally do not believe that intelligence of a sort that we have is inevitable. And instead of doing my own philosophy here, I would like to cite one of my favorite philosophers, Nicholas Rescher, who wrote about intelligence and science of aliens. And he had this example out there somewhere on some planet. There are moles who live underground. They cannot see, and they never saw the light. They do not understand the skies. They would not understand hydrogen line or anything. And since they live underground, they may communicate by the system that is not known to us, maybe some sort of electromagnetic things, which looks crazy initially, but we know now that some birds navigate through magnetic fields and so on. So I think there are different types of intelligence. And which type of intelligence will develop depends on the circumstances of evolution.
Okay, so the intelligence serves the organism in its environment, is what you're saying.
That is correct. And
So
also,
Max, go on.
I'm sorry, I just want to add one thing from my childhood. I know this may look like going back too much. Once I had a discussion with my father saying that how, only we are intelligent and insects, for example, are not intelligent. And he sent me to the library to get a book by Maurice Metternich, about bees. And after I read that book about bees, I said, I have to work on my own understanding, that we are the only species which is intelligent. Bees just develop in a different direction than us.
And bees communicate with each other in an abstract language that gives direction.
Yes, they do dances. Later, we found out recently, they do dances. They have very complicated way of communicating. And so we have other societies like ants and so on. So let us not be so anthropocentric to say, we are the only intelligent people on Earth.
So Max, is it possible that there's a life form out there that is so vastly greater than us in intelligence that it will not see us as intelligent at all? Are we to them what worms are to us? And the audacity of us to say, let's look for intelligence in the universe. On that scale, they would not even notice us at all.
If they're out there and see us, I think they would notice us. They might find us very arrogant when we start talking about ourselves as the pinnacle of intelligence, as some humans have done, right? But I actually have a minority view on this. I'm willing to bet with anyone else on this panel, with even odds, that we are the only species in our entire observable universe that's gotten as far as inventing telescopes. I can explain why that is in a little bit, but
what?
Yep. What? You're on for the bet. Good. What's at stake?
Meet me outside.
Good. And
wait, just to be clear, Seth, on my tie is an image of the Milky Way.
Yeah.
Show me.
How'd you get that picture?
I got people. I got people. So, how much of the Milky Way have we searched for? Has SETI looked for life?
Well, I mean, it depends on looked, your definition of looked, but sounds like President Clinton, I guess. And what I'm saying only is that if you say how much of the galaxy have we looked at very carefully over a large range of the radio dial, it's a few thousand, maybe 10,000, maybe 20,000 star systems. And as you know, there are 300 or 400 billion star systems.
You're talking about a speck.
Yes.
A tiny little volume.
Right.
Okay.
Yeah, it's a fly speck on your tie. Nobody will notice.
Yeah, but we cannot just consider the limits of our own technology and say we haven't looked yet, so we can't be sure. If you are a lizard,
is this your answer to the Fermi paradox, Max?
Yes, it is. Because if I'm a lizard living in the rainforest and I've only explored 10 square meters around where I live, and I can't just draw the conclusion that must mean that it could be all this. I can't draw strong conclusions about what's elsewhere in life on Earth, right? We humans have much more advanced technology than the lizards, and we've come there and screwed over the rainforest already in a really, really major way. And where I'm going with this is we also know from our own astronomical observations, right, that there's over 1 billion solar systems, many in our own galaxy that seem pretty inhabitable. And then there's another 100 billion or more galaxies in our observable universe. If any of those solar systems had developed a civilization with our level of technology 1 billion years ago or so, right, there's nothing in the laws of physics, if they wanted to, preventing them from building very advanced technological life and going out and really doing big things in our universe. We've talked about the history of life mostly so far in the panel, which is fascinating. But I think the future of life is very interesting too. And we paid tribute to Isaac Asimov today and to Charles Hayden. I just want to put in a tribute to Freeman Dyson as well, who left us this year, who wrote maybe the really first serious scientific article about the future possibilities of life in our universe. And if I had to summarize it in one sentence, what Freeman concluded, it was, you ain't seen nothing yet, right? He basically describes our universe as the Sahara Desert with a little oasis here on Earth. And maybe there is some other oases where Seth can find ET, but mostly it looks totally devoid of life.
We're with you on that. Where are you coming up with that we're the only ones with telescopes?
Yeah, for example. And so obviously you have to ask, well, what does that mean? And what Enrico Fermi said is, well, maybe it means that that life is for some reason much rarer than we thought. Though, yeah, it's hard to detect life that's trying to hide from us. Maybe there are, in fact, billions of other civilizations on all these planets there that are just all so excited about the video games they've developed that they've decided to not go out and do any large-scale cosmic engineering projects, and also
all in their parents' basement.
Yeah, in their parents' basement. But I actually think that's a very unconvincing scenario. You would only need one civilization that is like, hey, I'm going to build a Milky Way version of the Great Wall of China and start doing some Dyson spheres and rearrange my neighborhood. And
wait, Natalie's got something to say. Natalie, what are you trying to say?
Yeah, and of course, we can speculate about so much around that subject. But there is one thing, and I'm not saying that this is necessarily where my heart is going in terms of theories, but there might be something to be said about the possibility of generational aspect of life, which means that it may be, if we want to be really anthropocentric here, that the type of star or the type of material that's creating life as we know it is just, coming into life in the universe right now. And basically, we are the first manifestation of a type of life that we can recognize and can communicate with, and it will take a little bit more time. Look at us only 100 years ago or 200 years ago. The fastest way of going from point A to point B was the fastest horse you could buy. And now we are shooting spacecraft into space. So I'm not saying this is the right theory, but there might be something like that.
Wait, Carol,
I would agree somewhere that there is probably a lot more cyanobacteria in the universe than there is actually ET.
Carol, you wrote a book on the universality of life as we don't know it. Did I get that title correct?
No, it's called The Quest for a Universal Theory of Life, but it's about that topic. But I want to go back just briefly, because I think it's really important, to intelligence. Philosophers normally distinguish intelligence from sentience or self-awareness. And sentience and self-awareness have to do with the subjective point of view, this capacity of us to see the world as a unique point of view. And so that's what's really hard to define. I think that to characterize, philosophers are still struggling with understanding what it is to have a mind, not just intelligence, but to have a mind. And so I just wanted to mention that intelligence is not necessarily the same as being conscious or sentient. So I just wanted to mention that. But
Okay. Thank you. Seth, you've been trying to jump in.
Just very big. I have to respond to Max because he's essentially saying that there's no point in my career here. I'm going to take a paper route, Max. But I will say that I have to admire your audacity, because after all, what you're saying is, okay, we're the smartest things in the cosmos, and that's great, but isn't it a little self-referential? It could be that maybe your parents were a little too doting, right? And then they convince you of this idea.
I would much rather, of course, have a universe which is much more alive. First of all, I love what you're doing with SETI, and I love what everybody on this panel is doing for the professional job. When I say I'll bet you that we are the first life that's built telescopes, that means more than 50%. It doesn't mean 99.999%. Of course we should look. It would be the most important discovery ever if we find it, right? But we need to be humble also, and we can't just dismiss this by saying, well, maybe it's too early in our universe for any of this other stuff.
No.
We're a late bloomer solar system. We know that already.
The universe has had,
right, which have been here for over 1 billion years longer than us. So if most of them got as far as we did, it would take less than 1 million years for them to spread life throughout our galaxy and do all kind of cool stuff which they haven't. And I think I would just want to come back to Freeman again, because I think there's a great optimism in what he says. It's like you're looking out over the Sahara Desert from your oasis, and Freeman Dyson is saying it doesn't have to be this way forever. One day the Sahara can blossom with all sorts of life, right? And maybe
it's called global warming. Yeah,
it's on us, actually. Maybe
it was very green 10,000 years ago.
yes, exactly.
For some lucky reason, and it's up to us to try to not go extinct, and maybe the first extraterrestrial life on other solar systems.
Just to summarize, you're saying that you're content with the answer to the Fermi paradox that there is no truly advanced civilization out there. So there could be one, or there's not, but they encounter the same challenges we would have to populate the galaxy. That's what you're saying.
And also, though, I'm saying that these challenges are much smaller than we thought when you now factor in artificial intelligence. We don't have to wait for our human minds to invent all the clever...
Let the machine do it. Vera, what were you trying to say?
I just wanted to throw a monkey wrench into a discussion.
No!
By citing a very exciting paper.
Oh, wait, she froze up again.
Those Martians.
The Martians keep interrupting her communication.
Martian censorship.
Well, but one thing to note about what Max has said, there's no way for him to prove himself right, but there is a way to prove him wrong, right?
Yeah.
Math is trying to save his job.
Okay, wait, Vera's back. Vera, you're back.
Prediction.
Vera, you froze up there for a second.
I just wanted to bring up for Max to contemplate an idea of directed panspermia, which Leslie Orgel and Francis Crick proposed in 1970s, and they were initially ridiculed for it, but now everybody's sort of thinking about it, namely that life spread through the universe by intelligent beings who send essentially samples of life around in their spaceships of other means. And I think now, since we know about space travel, this became more interesting because Orgel and Crick felt that life was a rather rare event. And so maybe some very intelligent planet population, advanced technological population, came up with this way to transfer life elsewhere through the universe.
So there, Max.
There.
Yeah. I think we have a moral responsibility to not dismiss the possibility that we have this amazing responsibility on our shoulders, because I think we're really reckless, frankly, with how we take care of our planet. We're really terrible of it, right? And if we just tell us that's okay, if we have to go extinct because there are all these other civilizations we know they're going to bail us out, then we are likely to be even more reckless. I think we should be open to the possibility that maybe the destiny of life in our cosmos is up to us, and being better stewards of the Earth we have.
Well,
So we're running short on time. I just want to make sure I hit a couple of things. So Natalie, you have a book. You wrote a book, or co-authored a book on habitability on Mars. Is this? Do you want to terraform Mars? What's your objective with?
No, absolutely not. In fact, it's a collection of chapters where we are talking about the past habitability of Mars and the potential for life on Mars at the beginning of the history of Mars. So this is really a book that's looking at the potential for missions like Curiosity, where they should be looking at what type of environment, etc.
To find the life that might have been there back when it was
absolutely
a fertile haven. Very excellent there. And Carol, you have to tell me about your universal theory of life in 90 seconds.
I don't have a universal theory of life. What I do is I try to discuss. People have been searching for our universal theory of life since Aristotle. Aristotle thought he had a universal theory of life. And I argue in my book that biology is the only field that is still wedded to fundamental Aristotelian distinctions. Namely, Aristotle distinguished basically what we think of as metabolism, the ability to self-organize and maintain self-organization, and the ability to reproduce, which nowadays we have added, of course, with Darwin, with an hereditary system. And so we're still, if you look at theories of the origin of life, they divide along those lines. If you look at theories of the nature of life. They divide along those lines. And if you look at chemistry, we got rid of Aristotle's, five. Aristotle thought fire, earth, wind.
Elements.
Yeah, go on and on. And same with the Aristotelian idea that rest is the natural state of motion. And it was getting rid of those Aristotelian ideas that actually led to the flowering of the physics and also chemistry. And yet here we are in biology, still wedded, as revealed in theories of the origin of life and nature of life, to this bifurcation of fundamental characteristics of life. So
everybody's stuck. They're stuck, is what you're
we
saying.
need to go beyond the Aristotelian concepts. We need to do what physics and chemistry did.
To unify.
Well, not to unify, but to think of, to consider the possibility that our foundation for thinking about life is fundamentally mistaken.
Fundamentally mistaken. Well, let me end with one final question before we break in this format. Natalie, what is your favorite? This is like for Seth's benefit, right? Natalie, what is your favorite Hollywood alien and why?
I'm a totally, I am a sucker when it comes to that. I'm a romantic, so I go for E.T.
E.T. Oh, E.T. Very good. By the way, Steven Spielberg told me that when he created that character was a vegetable rather than an animal. And even though we want to think of it as an animal because it walked and talked and had fingers and things, but notice how good it was with plant life. It could touch plants and the plants would come back to life. So in his original thinking of that entity, it was a plant rather than an animal. So Vera, what's your favorite Hollywood alien? But can't hear you. Unmute.
The Martians.
Also E.T. for 3 reasons. It's cute, it's friendly, and there is a great representation of planetary protection during this movie. So also no violence, it is just very friendly. And another emotion of E.T., he is lonely for his home. So that is a very nice feature that I like very much.
And for those who don't remember the film or never saw it, the planetary protection is they set up this zone with sort of hazmat outfits when they had to operate on ET because they thought ET had died. But of course he didn't because it's a Steven Spielberg movie. So Carol, who's your favorite Hollywood alien?
E.T. is not my favorite. He's very anthropocentric in terms of a character. The Horta in Star Trek's Devil in the Dark is my favorite because it wasn't until they had a Vulcan mind meld, of all things, and discovered that it was a mother, talk about anthropocentric, that was protecting its young, that it suddenly was thought to be conscious and sentient and worthy of saving.
So the Horta was the silicon-based life that basically just looked like a rock.
That's
silicon
right.
being one of the active ingredients in so many rocks. And I remember that the babies were these perfect spherical eggs, but they were just rocks, right?
Right. And nobody would have ever thought, if it hadn't been for the Vulcan mind meld and the discovery of its anthropocentric characteristics, actually mammalian.
But mammalian, yeah, protecting its young, right?
Yeah,
right.
No, it was quite.
Very cool, very cool. And Seth, what do you have?
Yeah, well, E.T.
No, I'm going to come to you last because you're the
okay.
alien finder. Max, what's your favorite alien?
I'm gonna go with the aliens in the movie Contact.
Yes,
Because
that's a good movie too.
That's a little bit of a cop out, but I'll go.
no, but I'll explain it. It's because I always
A little bit of a
cringe
cop-out.
when I see aliens because they're so either so anthropomorphic or so in violation of the laws of physics. What I loved about the aliens in Contact is you don't see them, so I didn't cringe.
Okay, Seth.
Yeah, well, I got to say, I didn't know that little E.T. was actually a vegetable. I don't know if anybody else here is old enough to remember The Thing, a 1951 film, where the Thing from outer space was also a vegetable. They finally parboiled him with electric current. But my favorite is the alien from Alien. I thought he was just great. And that may be because, I have an uncle who was a dentist in Queens.
And
All right, if you have to think about it, it's not even worth thinking about it.
Or maybe Alf.
well, Alf was kind of fun with his sense of humor too.
Yeah, but he didn't have the bottom of his body. And he didn't.
You have to imagine it. Can I tell you my favorite alien? this, speaking as an astrophysicist and as a scientist, I have to say The Blob from the 1958 Steve McQueen movie. There's one that is not anthropomorphic at all. It's got no spinal column. It's got no mouth, eyes, hands, fingers. It's just the blob. And most people don't remember that when the blob landed on Earth, it was completely transparent. Only after it ate its first human did it turn red, and it was red for the whole rest of the movie. So this was a creature that defied any biological understanding of any way life could have been. And so I think of that every time when I want to wonder what exotic alien life might be. Well, panel, this has been highly illuminating and fun, and it's great to see all of your expertise coming together in angular ways to enlighten our audience. And so I just want to sort of give you an applause for that.